In this question, we've got two displacement vectors, one that's 300 kilometers north, which I'll call D1. And because it has a direction, I'm going to put the little vector symbol above it. And we also have 200 kilometers west, which I'll call D2. And we're trying to figure out two things, both the total distance traveled, which is not a vector, and the total displacement, which is a vector. Let's start with distance, because that's always the simplest. With distance, I don't worry about the directions. I simply add together the total path lengths to figure out my total distance. So notice I didn't put the arrows above to represent my scalar quantities. So D1 was 300 kilometers plus D2, which was 200 kilometers. I don't care about the north and the west. And that's going to give me a total distance of 500 kilometers. So my total distance, without worrying about the vectors, my total path length that that airplane covers is 500 kilometers. Now what about the displacement? Well, because they're vectors, I have to add them tip to tail. So if I add D1 plus D2, if I do this tip to tail notation, D1 is 300 kilometers north, so I'll start with that. So this might be a 300 kilometer north vector. That's D1. And then at the tip of D1, I start D2, which is 200 kilometers west, something like that. And when I place those two together tip to tail, I get a resultant that goes from the start of my diagram and points towards the finish. So my final answer will look like this pink line here. And we're trying to figure out what my total displacement is. Well, fortunately, we've got a nice right triangle, so we can simply use Pythagoras to find the magnitude of my total displacement. So d total squared will be 300 squared plus 200 squared. And then, of course, I would take a square root and come up with my answer. I'll let you guys do the math on that. And I get 361 kilometers. That's the length of that d total. Now the direction. If I want to find this little angle right here, I'll label it theta. Use your original values because you may have messed up your calculation for 361. And you can see that 200 is opposite and 300 is adjacent. So I can use my any old trig function because it's a right triangle, but I choose to use tan because I know the opposite and adjacent. So I get tan of theta is opposite over adjacent. And of course, to find the angle, you have to do the second function, or inverse tan. Tan inverse of 200 over 300. Find that on your calculator and you get 34 degrees. And since this is swinging to the west from the north line, I would say west of north. So we have both our magnitude, which is 361 kilometers, and our direction, 34 degrees west of north. And we string those together to get my total displacement of 361 kilometers at 34 degrees west of the north line.